All right, so here in 11.7, we're going to talk about events including and, so conditional probability and events including and. And the first thing we want to talk about is independent events. And for independent events, the occurrence of one event has no effect on the probability of another event occurring. Okay, so just because one event occurs does not mean the other event has anything to do with it. It means these two things are separated. Okay, so if A and B are independent events, that means the probability of A and B occurring, we just multiply the probability of A times the probability of B. All right, let's, for example, we're going to look at a probability of family having 4 boys in a row. All right, assuming that having a boy and a girl has equal probability, you're going to get one or the other. So the probability of having your first boy is 1/2. Okay, so you're either going to get a boy or a girl. You have a 1 in 2 chance of having a boy. If the probability of second boy is going to be the same, is 1/2. Probability of having the third boy is 1/2. And the probability of having your fourth boy in a row is 1/2. All right, and all we do is multiply these probabilities together. And the probability of a family having 4 boys in a row is 1 to 16. Okay, so it's pretty straightforward. Let's go ahead and look at another one. So I'm going to look at a single die. Now, a single die, every time you roll it, it's fresh. Okay, so you don't have to worry about if you roll a number, you can never get that number again. That makes this an independent event. Okay, so I want to look at the probability of that I get a 2 the first time and a 3 the second. Okay, now we're assuming this is a 6-sided die. So the probability of rolling a 2 out of 6 sides is 1/6. Okay. The probability of rolling a 3 is also 1/6. Because just the fact that I rolled the 2 the first time does not affect that I can't roll the 3 the second time. It's the same probability, same die. So the probability of getting a 2 the first time and a 3 the second time is 1/36. Okay, part B is a little bit more interesting. Okay, so if I want to roll an even number the first time, so we're taking the same single die, we're going to roll it 2 times. The first time, we want the probability of getting a even number. Okay, so out of 6 sides, there are 3 even numbers, 2, 4, and 6, out of the 6-sided die. The second time I roll it, I want a number greater than 2. Okay, so the numbers greater than 2 on a die are 3, 4, 5, and 6. That's 4 numbers. So numbers greater than 2 are 4 out of the 6 sides. Okay, if I multiply them together, I get 12/36. Remember, these are fractions. We got to go ahead and simplify it into lowest terms. It is 1/3. Okay, and this also works for decks of cards. The only thing you got to worry about with decks of cards is when you draw a card out, it takes it out of the mix. Okay, so what you got to make sure is that the card that you pick is placed back inside the deck. Okay, and this is something that's called with replacement. So if you have cards drawn and that card is put back into the deck and reshuffled, okay, then this works for that with cards. Otherwise, when you draw a card, it takes away from it. We're going to do a bunch of examples with cards later on where that it does not happen, where we draw the card and it's done. Okay, but keep in mind, this idea works as long as the card that you draw is placed back into the deck before you draw again. All right. So let's go ahead and look at the probability of an event happening at least once. Okay, so we want to look at the probability that it happens at least once. And what we do is we take 1 and subtract it from the probability that that event does not happen at all. Okay, and we're going to look at hurricanes in South Florida. So we want to look at the probability of South Florida having a Category 4 or 5 hurricane. They tell us in a single year that is 1 over 16. Right? So I want to look at what's the probability of having a major hurricane here 2 years in a row. Okay, so the probability of it happening in a single year, okay, is 1 over 16. This is going to happen to us 2 years in a row. So we again can multiply it by 1 over 16. You may also see it notated in your book as just going ahead and squaring it for the number of years in a row. And this gives you 1 over 256. Okay, so the probability of it happening in 1 year at least once is 1 over 16. If it's 2 years in a row, we multiply it together. It works just like the event before, where we have independent events, right? So now we're going to look at what will happen if we will not be hit for the next 10 years. Okay, so the probability of getting hit by a hurricane in a year is given to us as 1 over 16. The probability of not getting hit will be 1 minus 1 over 16, which is 15 over 16. Okay. So the probability that it does not happen here, okay, probability that it happens, the probability that does not happen is 15 over 16. We're looking at the next 10 years, and they give you the option of doing decimals or fractions with this. Decimals, it wants usually to 3 decimal places. So for the next 10 years of not being hit by a hurricane, the probability is around 0.524. Okay, expressing this as a fraction is kind of messy, so here we were looking for the decimal because it is so long. Now you're saying, well, what happens here? Because it says the probability that it does not happen. But now we only look for if it does happen, which was part A. If it does not happen, it's part C. So these were pretty much independent events. Now we're going to look at least once, and this is where we're going to use our formula. Okay, so the probability of happening at least once is 1 minus the probability that it does not happen in the next 10 years. We did that in the above problem. That is this number, and I'm going to go ahead and use the decimal. So the probability of it not happening at least once, that it will happen at least once in the next 10 years, sorry I misspoke, 0.476. Okay, so the first two were actually independent events. All right, where we just had to find the probability of it not being hit, which is 1 minus 1 over 16. But once we had that value here, we could look at least once. This is what you're looking for, at least once, in order to go ahead and use this formula. Right? Going ahead, we're going to go ahead and look at dependent events. Okay. Dependent events are the occurrence of one event that has effect on the probability of another. Okay, this is the deck of cards stuff that I was talking about earlier. Okay, because if you go ahead and have a deck of cards and you draw one card, you have automatically, first of all, reduced the number of cards left over. So if you have 52 cards, you take out one, you're left with 51. And then that card is also out of the mix. All right. So our probability of A and B occurring is we have to look at the probability of A times the probability of B given that A has already happened. All right. And we're going to look at a few examples here. We're going to look at example 6. So you are dealt 2 cards. It's from a 52 card deck. Okay, I didn't write that in there. And I want to know the probability of getting 2 kings, okay? Well, the first time I draw a card from a 52 card deck, there are 4 kings in that deck. So when I draw a card the first time, I have a probability of getting one of those 4 kings out of the 52 card deck. All right. Once we go ahead and look at that, then it's like, what's the probability of getting 2 more another king? Okay. So we took 2 cards at the same time from the 52 card deck. But if I got a king the first time, there are only 3 kings left. So now they only have 3 kings to choose from. When I go ahead, multiply this together, I get 12 over 2652, which simplifies to 1 over 221. Okay, because I drew these cards at the same time, I still drew them from the same 52 card deck. All right, but out of if I get a king the first time out of these 4, then I'm only left with 3 to try to get my second king. All right, let's go ahead and look at example 7. I'm dealt 3 cards out of that 52 card deck, and I want to know the probability. This is incorrect. This should be 51. I'm sorry, because you took an extra card out. My apologies. So the second one is we have 3 cards. We want to get 3 hearts. Well, hearts, each suite or each suit has 13 cards. So the probability of getting my first heart is 13 out of 52. I'm sorry if example 6 was confusing. Talk to me later if you have problems. If I want to get a second heart and this first one was successful, that means I only have 12 of the heart suits left. And I have 51 cards left. In order to get my third heart, assuming the first 2 are successful, that means I have 11 cards left out of 50. All right. And when I multiply these together, I get 1716 over 132,600, which simplifies to 11 over 850. All right. This number could be wrong here. I'll go ahead and verify that because my denominator changed, and I'll make that correction. But I should have changed that to 51. Because it's a dependent event, not an independent event. So independent event, that number would stay the same for cards. Because it's a dependent event, that number had to change. All right, conditional probability. Okay, so the probability of event B happening, assuming that A has already occurred. All right, so these are intertwined together. And the formula is, this is the probability of B assuming A has occurred. The formula is the number of things that B and A have in common, the number of things that B and A have in common over the outcomes of A. All right. This sounds kind of weird, but let's go ahead and look at this example 10 on 142. I want to know the probability of getting a black card given that you are dealt a spade. Okay. Now, all spades are black cards. So the probability of you getting a black card if you were dealt a spade is 1. You already got that card. You were given a black card because all spades are black cards. Okay, so if we were to look at it with the formula, a black card and a spade is a 1. Spades are also 1, so it ends up being 1, if you want to actually use the formula for this. The probability of getting a spade given you drew a black card. Okay, so each suit is 13. Spades and clubs are both black cards, so black cards are 26. So the probability of getting a spade given you were given a black card, the number of black cards, my only A is 26. My number of spades, the suit is 13. So your probability here is 1/2. All right. So I hope this cleared everything up. Make sure that when you're doing the dependent events that you're also taking one of those things out of the mix, especially important with cards. If you have any questions, make sure you go ahead, reach out to me, and I will see you in the next video.